When an MCP server acts for a user, trust has to travel with the request. In this section, we'll connect delegation, explicit consent, secure execution, and audit trails, so powerful tools remain user-authorized, controlled, and accountable. So far, we've built the foundation: production MCP servers, then authentication and authorization. Now we move from controlling who can access the server to safely allowing tools to act with a user's permission. In production, an MCP server is rarely just answering questions. It may touch email, calendars, tickets, documents, repositories, or cloud resources. That raises a central security question: whose authority is being used? If the server acts as itself, broad service credentials can quietly bypass least privilege. If it acts only as an application, permissions may still be too coarse for user-specific work. Delegation lets the action run on behalf of Alice, within Alice's actual permissions. That creates safer boundaries, stronger audit trails, and clearer accountability when business systems are changed. In this flow, the tool request begins with an authenticated user, not just an autonomous service. The MCP server receives the request, validates the user context, and determines whether the action needs delegated access. If it does, the server obtains or exchanges for credentials that are bound to that user and scoped to their permissions. The downstream API then sees an action performed as the user with the same limits the user normally has. The key rule is simple: do not replace user authorization with broad service credentials just to make the call easier. Delegation is not one size fits all. Passing through the user token is simple and preserves user context, but it exposes that token to more systems and depends on downstream APIs accepting it. Token exchange adds a step, but gives you a narrower, purpose-built token that usually supports least privilege better. Service mediation can help when APIs only support service credentials, but then the MCP server must enforce user policy and audit every action carefully. In production, favor the model that minimizes token exposure while preserving accountability. A delegated tool call should never jump straight from request to action. First, verify both identities, the human user and the AI client acting for them. Then, evaluate the requested tool, its arguments, and the target resource against policy. If consent is missing, expired, or too broad, pause and deny or confirm before continuing. Only after that should the server retrieve or exchange a user-bound access token for the downstream system. The action runs with scoped authority, and every decision, token event, call, result, and denial is captured for audit. Least privilege delegation means the agent receives only the authority needed for this request, not a copy of the user's full account power. Start with deny by default, then grant narrowly. Which tool may run, which action it may take, which resource it may touch, and for how long. Authorization should consider the tool name, inputs, user role, tenant, and downstream system. Avoid storing long-lived delegated tokens in the MCP server. If a token is reusable, broad, or context-free, it becomes a standing invitation for abuse. Consent and confirmation solve different problems. Consent establishes general authorization. The AI client and MCP server may use certain tools, data, or scopes under defined policy. Confirmation is narrower and immediate. It asks, are you sure before this specific action happens? That extra step is required for destructive changes, payments, external messages, privilege changes, or anything hard to reverse. Read-only, low-risk actions can usually proceed under existing consent. What matters is timing and clarity. Ask before execution and explain the system, action, and data involved. Think of confirmation like signing a contract, not handing over a blank check. Allow access is too broad when an assistant can move money, send files, or change permissions. A safe confirmation names the tool, the resource, the action, the key arguments, and the expected result. If any material detail changes, such as recipient, amount, tenant, file, or destination, ask again. Where possible, show a preview or use idempotent operations first, so approval commits exactly what the user understood. When an AI prepares an action, consent has to translate intent into consequences. The user should see a plain language summary, the tool being invoked, the system affected, and the data that will be used. For higher risk actions, separate the experience into preview, confirm, and execute. Preview lets the user inspect what will happen. Confirm creates an explicit decision point. Execute happens only after valid permission. If permission is denied, cancelled, or expires, fail safely with a clear message. Good consent UX makes automation feel controlled, not surprising. Treat consent as a living state, not a checkbox you store forever. Some approvals should be single-use, especially for sensitive or unusual actions. Others can last for a session, a fixed time window, or repeat safely as durable delegated consent. The important question is what ends that permission? Elapsed time, logout, increased risk, or changed parameters. Users must be able to revoke access, and administrators may need that power too. Finally, recheck policy at execution time, because roles, tenant membership, and downstream permissions can change after consent was granted. Accountability in delegation is a chain, not a single log entry. You need to know which user initiated the request, which AI client chose the tool, what the MCP server executed, and what the downstream system returned. Each stage should record the minimum useful facts: tool name, inputs, policy decision, consent, timestamp, and status. Connect those records with a shared correlation or trace ID, so an investigation can reconstruct the full path. Just as important, keep secrets out of logs. Never store raw tokens or unnecessary personal data. Make audit data structured and queryable. For delegated MCP actions, an audit record is not just a log line. It is the evidence chain. Capture who acted, which tenant they belong to, which AI client invoked, which tool, what resources were touched, and whether the action succeeded. Add the authorization context: policy version, scopes used, consent reference, token exchange, decision reason, and risk level. Operational data matters too, including timestamps, request IDs, trace IDs, endpoints, latency, and error categories. Finally, protect the record itself with append-only storage, tight access controls, retention rules, and alerts for unusual patterns. Most production failures in delegation are not cryptographic failures. They are boundary failures. The client asks for more than the user intended or changes arguments after approval. Confirmation must be bound to the exact action, parameters, and target resource. If a server uses service credentials for user work, policy must mediate tightly, or better, use user-bound delegation. Logs need enough structure to reconstruct the chain: user, client, tool, downstream action, and correlation ID. Consent should expire, be revocable, and require reauthorization when risk or scope changes. And enforcement must stay server-side. Prompts are not controls. The main pattern is straightforward. MCP servers should act with delegated authority, explicit consent, and durable evidence. Permissions stay tied to the user and the task. Approvals match the risk and the exact action. Audit records connect every participant in the chain. Next, we extend these ideas into tenant isolation, data boundaries, secrets, tokens, and stronger operational auditability.